Good morning to one and all present here, and a warm welcome to the fifth day virtual symposium on aquaculture industries and trends in aquaculture industries. And a kind information to the participants: please mute your audio and disable your video so that the session goes smoothly. And I welcome Dr. D. Inbakandan, Head and Scientist of Center for Ocean Research, Sathyabama University, and our guest speaker, Dr. Victor Suresh. Shall we go with the introduction part, sir?
Please.
Thank you, sir. Dr. Victor Suresh received his higher education in aquaculture and entered into the feed sector in R&D, product development and formulation. He has been working in the sector for the last 24 years. His consulting firm United Research was founded in Singapore in 2011 and has fed manufacturers in India, Bangladesh, Indonesia and Saudi Arabia as clients. He is also associated with the feed additives and supplements company Bentoli for a number of years. In India, he serves as the technical director for Grovel Feeds Private Limited. Recently, he has become the president of the Society of Aquaculture Professionals for the 2020 to 2022 term. Presently, he is the managing director of United Research Singapore Private Limited since 2013. With pride and honor, we welcome you to give the talk on advances in aquaculture nutrition research. Thank you, sir. The session is over to you. Please carry on, sir.
Okay, thank you very much.
Thank you.
I would like to thank Sathyabama University, Dr. Inbakandan, for inviting me to speak, and Ms. Anu Chandrasekhar. Thank you very much for your kind introduction. I would like to ask if I'm coming through clearly, because when Ms. Anu was speaking, I couldn't hear her completely clearly, and I'm not sure if it is a problem on my side or on your side, but can everyone can hear me clearly? I think if you don't, in our home, the Wi-Fi signal is somewhere else, and I'm sitting here. I could try to go closer, but I prefer not to. This is a good place for me to talk. So if people have problem, let me know.
Anyway, you have to kindly check your Wi-Fi connections because your voice is breaking
My
sometimes.
voice is breaking. Okay, let me
Yeah.
let me try another location,
Yes.
in case if that's gonna help in any way. I just need to turn around and go the other way, and which puts it closer to the. In here, you won't be able to see me very clearly, but you might be able to hear me better. Is this better?
Yes.
Yeah.
No problem.
Yeah. Okay. Okay. And so when I was speaking to Dr. Inba, I was asking what would be the typical audience for this meeting, and he said a lot of students will be there, researchers will be there, as well as other people, and it would be beneficial. And he emphasized that this is one in which we bring in people who are working in the industry to come and make a presentation to people who are in a wide variety of environment, including academic environment. So I structured my presentation according to that. And one of the things as we start is that we have this Society of Aquaculture Professionals. I don't know how many of you know about it, but we have been in aquaculture in the industry for almost 2000, from 2003. We have more than 500 life members. We organize a program called AQUA India, which is a very important aquaculture event in India, maybe the most well-attended event. It happens every 2 years. We had it in 2020. And fortunately, just before the lockdown started, it was the end of January 31st and February 1st was the AQUA India 2020. So we have the next program in 2022. Hopefully, by then lockdown will be gone, and we'll be able to attend it. And then one of the things that I want to bring to everyone's attention is that we started opening memberships to students in aquaculture from this year onwards. So, so recently I have become the president for this association for the next 2 years. And so, we are putting a lot of emphasis on this student membership. So students are very welcome to contact me. You can go to the website. The website address is just below the logo. You can go there and check it out. The website is being updated now. So what you will see on the website is a little bit of an older information, but we are in the process of working on an update. In another 15 days, by the middle of August, we should have the new website working. But again, the contact information and everything on the website would remain the same. Okay. So one more check on the voice audio. Is it okay?
Okay. Yes, sir.
Yes, sir.
Okay. Okay. Okay.
Yes,
Wonderful. Okay. So when you are looking at this aquaculture nutrition, when it relates to what we do in the industry, there are 5 important things, that are the subject areas that are most important. One would be nutrient requirements of the animal, and this nutrient requirement would change based on species. It changes based on the life stage, which is whether it's a juvenile or an adult or a larvae or a broodstock. Based on the life stage, the nutrient requirement would change. And also the farming system, how intensively are you rearing the animal in, whether you're putting it into a pond or a recirculating system, whatever system that you're using is going to have an impact on the nutrient requirement. The other part is that a nutritionist need to understand the ingredients, the feed ingredients. And the feed ingredients, again, the composition of the feed ingredients, which would change from time to time based on, where they're growing and at what stage of culture, that we are harvesting those raw materials. All of that would affect the composition, the digestibility of it, what would be the minimum and the maximum value that we should have for a particular ingredient in the feed, and which would, based on some of the anti-nutrient factors and other things, would determine the inclusion of the raw material. People who are in aquaculture nutrition also need to understand feed processing technology. There are a variety of ways to make the feed. You can pellet it, you can extrude it, and then after you pellet or extrude, you can crumble it. Or you could produce some of the very small size particles on-site production of particles. All of that, people need to have an understanding, because feed processing technology would have an impact on the nutrient content of the feed and the availability of nutrients and so forth. So a deep understanding of the feed processing technology is important. We need to understand the feed additives. What are they made of? How do they work, and what is the dosage that we need? The safety aspects of the feed additives are important, so people need to have an understanding of that. And finally, we need to understand what feed has an effect on water quality, fish health, or finally fish quality as human food. This is becoming extremely important. And when I was talking to Dr. Inbakandan, he mentioned that you are looking at post-harvest processing. Again, aquaculture and the feed that we provide will have an effect on its quality, when you process it, so that part also is extremely important. Now, when you look at the nutrition research that's conducted in aquaculture, you can divide them into 2 different categories. One is public research. This is universities and research institutions conducting research, largely supported by public funds. So the results of these research are made public. They are public, they are shared openly, so everyone has access to it. Or we can do private research. Again, a private research can be done at a university or research institution, but then it is funded by the private enterprise. And then the collaborative research among feed manufacturers and their suppliers and customers. This is extremely important. Is that we work closely with our suppliers, we closely work with the feed manufacturers, and this collaborative research is an important part. And finally, the in-house R&D, for the feed manufacturer is also very, very important. And this in-house R&D, is something that I'm going to go deep into as I make my presentation. And one thing I want to find out, I tell you is that now a lot of private research organizations are also coming up. So these private research organizations, are extremely, only, based on the support by the customers, who can be feed manufacturers or feed additive suppliers or even feed companies. Basically they are involved in providing this collaborative support, to the to whoever is willing to pay. They can conduct trials and do the work for them. So it is an increasing activity. I'm seeing a lot of individuals who are going in that direction, setting up their own R&D facility and then offering it as a service to whoever wants to use it. I'm seeing more and more of that coming up. Now, when you look at the publications, to understand how much of an increase that we have in our research, we see that it has increased many, many times. And so in order to document that, I was looking at what has happened in the last 20 years in terms of publications that come out in a particular journal called Aquaculture Nutrition. And over time, this journal has become bigger, and it's now doing, 3 times more papers than what it used to be. So it shows that the content of aquaculture nutrition research has grown over time. And so more knowledge is available today than in the past about the nutrition of the animal. Now, when we break it down and then look at what species are targeted, one of the interesting things is that there are top 5 species, and they are there. The carps, the tilapia, catfish, shrimp, salmon. If you look at fish production, fed aquatic animal production, these 5 species are responsible for 90% of the production. For 90% of the aquaculture come from these 5 groups: carps, tilapia, catfish, shrimp, and salmonids. And about 50% of the work is on this 90% of the species. The other 50%, are on 30 to 40 species. When you look at the number of species that are cultured, if you go and look at the FAO data, you see that there are more than 100 species, 100 species that are cultured. And there are like 30, 40 species that are cultured. Maybe their volume is not that great. There are species that are only produced, maybe a few hundred tons also, are being produced. But a lot of work is done on these species, so you see that the funding actually goes into, these species that are in early stages of development, that not much is understood on this species, and then there is quite a bit of work done on those species. Whereas on the established species, the only 50% of the work goes. This is somewhat understandable. And also you can see that among the species group, one notable trend is that you see this salmonid work going down. Okay, and whether it's really going down or another factor, I think it's another factor, and we'll look at it in the next slide. So this is looking at where the research is conducted, and when you see it, it's very, very obvious that globally the aquaculture research has moved very strongly to China, and this is true of most of the scientific research, is that there is an increasing amount of scientific productivity from China, and aquaculture is no exception. It's understandable also because aquaculture, China is the largest aquaculture producing country in the world. It produces more fish than a lot of, I think, 2-3 countries after China, China produces more fish than those countries. So, so obviously, when these Chinese universities and research institutions get a lot of funding these days, and a lot of aquaculture nutrition work gets done in China than in other countries. Other parts of Asia, not much change over the 20 years. When you look at Europe, particularly Norway, Norway used to be a very strong in aquaculture nutrition research, and it has gone down quite substantially. And this is why you also see that the salmonid work that we saw earlier, the decline is also over here. And then when we see why it's happening, one is, there's quite a bit of historical good work done on the salmonid nutrition. Secondly, a lot of work has gone private. Okay, it's not published anymore. There are these very large salmon feed companies today. There are 3 of them that dominate the world, and in terms of the salmon feed, and they are now in other species also. They do a lot of work in-house. So this work doesn't get into the public domain. It remains, as the intellectual property of these companies that are doing that, and that's one of the reasons why we see this decline in the amount of publications. And another sad thing is the USA and Canada used to be a big contributor to the aquaculture nutrition research. We don't see their contribution in terms of the number of papers. Still, there are good nutritionists in those 2 countries, and they still contribute, quality papers. But we don't see the productivity as much as it used to be. It's far less today than in the past. But we see, quite a bit of work coming from Latin America, the Africa and the Middle East, particularly from the Middle East. We see a lot of good work. Australia is again like Europe and USA and Canada. There used to be a lot of productive output from Australia, but it's now on the decline. So this is today's situation. So today, a lot of important work, gets done in China, which becomes a big contributor to the aquaculture nutrition work. So what are the different areas? When we started this presentation, we talked about 5 different areas that are important for aquaculture nutritionists to understand. And you see that there is a lot of work that used to be done on the nutrient requirements of the species. It's not that we understand every nutrient requirement of every species that is being cultured, but increasingly there is emphasis on the ingredients. This is very important because we need to understand the ingredients for practical application. It's very important that we understand the ingredient composition, digestibility, and so forth. So more and more of that work, is getting done on the ingredient side. There is an increasing work on the health side, although not as much as I would like to see, but it surely is much more than what used to be done. And then we have enzymes. We have other topics, miscellaneous topics that get done. So this gives you a little bit of an overview of for those who are students and who are in the institutions involved in research or private companies involved in research. This is just a perspective. Now, moving on to the next area, when we look at what are the major concerns of the global shrimp culture industry, I'm using shrimp cultures more as a surrogate for the general aquaculture because I'm more familiar with it, and also it's a very important sector in terms of its value. It's one of the highest value sectors. So I'm taking shrimp culture as an example. 2 things. One is disease, another one is feed cost. This is something based on this Global Aquaculture Alliance, which is a global organization. Society of Aquaculture Professionals that I talked about is actually a strategic partner to Global Aquaculture Alliance. And they conduct an industry-wide survey every year. And consistently, these 2 topics are on the minds of the people: disease, feed cost. Feed cost because it impacts the production cost. About 50 to 60% of the production costs in aquaculture come from feed. So there has been an increasing emphasis on the efficiency People want to see a lower cost feed so that their production cost can decrease. And when you look at the external challenge, what is the public perception of aquaculture? The public perception of aquaculture has been negative at times. It's been going up and down. Sometimes we get good press. Sometimes most of the time we get bad press. And so the general perception of the public is that it's environmentally polluting. It is not sustainable because of the reliance on fish meal and fish oil produced from the wild fish. That it relies on antibiotics for disease management. It produces seafood that is inferior when you compare it to wild-caught seafood in taste, texture, and other health benefits. It's lower. But the truth is that scientists, research community, even the industry has been working together on all these issues, and they have made a lot of progress, and this doesn't get the press that it deserves, but only the negative messages come across. So a lot of work has been done, in managing these aspects in the past. So I would like to, really in my slides that are coming through, I want to emphasize, what has been done to highlight, what can be done and what should be done. And so you get an idea of, the contribution of the private sector. So basically, when you look at this, you have a good reduction in the fish meal levels in the feeds. You're looking at whether it is carp or tilapia, which are herbivorous fish or omnivorous fish. They don't need as much fish meal to begin with, and their levels have gone down quite significantly in the 20 years. Salmonids, again, their levels have gone down. Shrimp, their levels have gone down. So there is a consistent reduction in terms of fish meal use. This is largely because of scientific research that has been done. So the priority areas, when you look at them, what you see is how do we reduce the fish meal and fish oil that are coming from the wild fish, but at the same time, we don't want to compromise fish performance, fish health, and human health. All these are very important. So when we look at it, we are looking at sustainably and cost-effectively produce novel proteins and fats. For example, there are fermentation technologies. These are producing single-cell proteins, and you can take a seafood waste and then recycle that into either a fish meal or a fish hydrolysate, and produces some of the functional biopeptides. And also you can produce algal and vegetable oils rich in highly unsaturated fatty acid. So these are, you can continue to, you don't have to rely on the wild produced fish, wild caught fish, in producing the fish meal and fish oil that are necessary for aquaculture's growth. Also, these are, just the ingredients alone are not enough, but we also need to have nutritional and functional supplements. And these are amino acids, minerals, water-soluble vitamins that leach less and assimilated more efficiently. And this is an important part, is that solutions are available for livestock, but the solutions for aquaculture need to be different, because once you throw your feed into the water, the nutrients start leaching out. So unlike in livestock feed, where they don't have that challenge, the nutrients that we are supplementing need to have these in a form that will leach less and be assimilated more efficiently. And also the attractants and palatability enhancers are important. So if you give a complete vegetarian diet, that the fish are not used to, they need to have these attractants so they can identify the feed and go towards that, and then also consume the feed. So today, there is a lot of work that is getting done on understanding some of the chemicals that are important in providing the signals, and then providing them as attractants and palatability enhancers. So a lot of work gets done in this particular area. So this is some of the work that we ourselves did. in order to understand, these ingredients, that play a role as fish meal replacement, we were largely looking at animal byproducts. These are poultry byproduct meal, feather meal, blood meal. And then we compared them, with the marine ingredients, the fish meal, fish hydrolysate, krill meal, and the squid liver meal, and saw, how different they are. And they are vastly different. The one that worked well as attractant and palatability are very high in peptides that are short chain peptides. So you see here, the one on the top, the pink bars are less than 1,000 Dalton or 1 kilodalton. These are very small small peptides, and also free amino acids. And you can see how rich the marine ingredients are in those when you compare them to the animal byproduct. The animal byproducts are on the left-hand side of this chart, and the marine ingredients are on the right-hand side of the chart. And you can see, in the distribution, the animal, particularly when you look at something like a blood meal or feather meal, these are very, very large peptides. And so these peptides, the short chain peptides actually are also the good attractants. They are the ones that are providing the smell characteristics that are important for the fish and shrimp to follow. So we were also looking at the nucleotides. And again, in the nucleotides, you can see this vast difference between these different kinds of ingredients. The marine ingredients are much higher in terms of the nucleotides when you compare them with the animal byproducts. And so ultimately, okay, you can do all your research in your research institution, in your lab, but then when it comes to a commercial solution, it needs to have, partly the formulator, who's looking at the requirements of the species, is looking at the characteristics of the ingredient and try to match them together using a formulation program. But also it requires product solutions in terms of, we talked about the supplements, when we talk about amino acids and trace minerals, how do we make them less soluble? How do we make them as effective as they would be if they were part of a fish meal? So when you are taking a crystalline amino acid, whether you are taking a lysine or a methionine, how can you ensure that this would be as effective as the lysine and methionine that come from an intact protein like a fish meal? So the same thing with the functional ingredient, whether it is an attractant or enzyme to improve the digestibility of the ingredient, you need product solutions, in this. And then you also have the alternative proteins. These alternative proteins can be terrestrial animal byproducts, it can be algal meals, it can be single cell proteins, or any of those solutions. How do we put them all together to provide a fish meal replacement? So the other important part, we were talking about fish meal replacement in that, we talked about it's not simply the performance of the animal, but also the health of the animal is very important. So health is an important performance factor. And also, ultimately, this is the fish that's going to be consumed by people. So again, the reason, one of the reasons, people eat fish is to be healthy. Okay. And so in the fish that is wild caught, you have this highly unsaturated fatty acids, you have that bring them human health benefits. And how do we, again, provide that to the animal? And those factors that provide health to people also provide health to the farmed animals, farmed species. So how do we improve the aquatic animal health using dietary factors? So again, multiple choices are available. One is to improve the gut health by using prebiotics, probiotics, acidifiers, essential oils, and so forth. And then we can also have nutrients that promote immunity. Vitamins, for example, vitamin C and vitamin E. You have trace minerals like selenium. These are nutrients that promote immunity. So they're part of, they improve the performance of the animal. At the same time, they also improve the health of the animal. But there are also non-nutrient immunostimulants, things like the yeast cell wall components, that trigger the immunity in the animal. So they don't have a nutritional benefit, but they have an immunity benefit, a health benefit in the feed. So so there is a lot of need, to work on those areas. How do we improve the health of the animal using nutrition. So there are multiple ways to manage the health of the animal, but nutrition is one of them. And it is the duty of the feed manufacturer to really address that that aspect. However much we can do on that side, it is desirable. So now I'm coming to the third and the final part of my presentation. How do we take an idea which can be coming from the feed mill side, or it can be coming from the farmer side, but whatever it is, the idea is coming, and then how do we convert that into a product? So in this particular case, I'm going to describe how we did for one of my clients, and I wanted to give that as an example of how research in the industry gets done. So this is the Growell Innovation Center, which where we conduct all of our trial. And by the way, earlier this month, this lab was recognized by the Department of Scientific and Industrial Research. So it's recognized by the DSIR. And basically, this has been in place for the last 5 years. And this has different components to it. And I'd like to walk you through the different components. One is the pilot feed plant. So the big feed plant, where we make the commercial scale feed, the smallest capacity of the machine is about 5 tons per hour. So it's a very large capacity, So if you want to make a little feed for your trial, you cannot use it in the big machine. The big machines are used anyway in commercial operation. You cannot go and do it. So there is a need to have a small feed mill, and so this is what it is. And this is mostly manually operated machine. And so on your left-hand side, you see the view of the pilot plant, and at the very front of it is the coater, but there is also a cooler after that, which you don't see in this picture. And the long box that you see over here, I don't know if you could see my 1 second, if there is a pointer there. I'm not very sure if you can see my pointer, but it's basically a dryer, and then you see the other part, where you're seeing the grinding setup. This is where the grinding happens, and then it comes into. We have 2 extruders here. One is a single screw, another one is a twin screw extruder. The picture is a little bit small, but over here at the very center, the bottom left-hand side, is where you see the small extruder. This is a twin screw that you see on the side of it. There is a single screw extruder, and so these machines help us to make feed. Actually we can make a feed that as good as a commercial scale feed, but we can make 10 to 100 kilos per hour instead of making 5 tons per hour, or 10 tons per hour. You can make a smaller quantity. So you can do a variety of feeds. We can test. Even in the system, we can also optimize the process, and then we can take it to the bigger plant and do the feed, over there. We have animal rearing facilities. There are 2 units here, and one is where we have this fiber tanks and also aquarium tanks, and you can see them at the top. There are 80 tanks here, and they are connected to 2 different systems. One on one side, it is connected. The one that you see on the left-hand side is the clear water system. This is basically a recirculating aquaculture system. It has a solid filter, a biofilter, and also a UV disinfection unit to take the water into the system. So it's clear water. There is no organisms in this system. On the other side, we are connecting it to a green water system. The green water system is basically on the outside, and it's almost like a little pond. It's exposed to the sun, so it generates a lot of algae, and we take that water and we circulate into the indoor tanks. So the water gets processed, through this algae. We also have some fish in there. We actually stock them with tilapia and milkfish. And we don't feed the milkfish or tilapia. They are completely eating the algae and whatever waste that is generated coming into the system. They consume that waste and they grow. And so we have two different systems. So some of the things, when we want to understand the specific shrimp nutrient requirement without any interference of any of the organisms, any algae or any zooplankton, then we can do it in the clear water system. When we want to know how it would be like in a pond environment, then we put it into the green water system and we can run trials. So we have 40 plus 40 tanks in here. We also set up cages in the pond. It's right beside our feed mill. So in this pond, we have cages. We have close to 120 cages here, and this is actually very low salinity water. I would say 1.5 ppt. So you can have both fish and shrimp can grow in these cages. And so we do trials, feeding trials with both fish and shrimp in these trials, and we get fairly good growth rate in these systems. The shrimp grow like they grow in the pond, and so these cages are being used to try to conduct feeding trials on shrimp. This is not our own facility. This is something that we would love to have in the future, but right now we don't have it. So this is, when you are studying the health aspect, when you want to have a very controlled pathogen challenge test. So this is a lab in Vietnam called Shrimp Lab. Earlier in my presentation, I talked to you that there are also now labs that are for profit, and that's the service that they provide to the industry. This is one such lab. It basically provides service to anyone who is willing to pay for a trial. And so in this trial, you can basically grow the animal and subject them to any of the pathogen. You can do white spot virus. You can do the bacteria that causes CMS. All of those control trials can be done here. Like I said, we don't have access to a lab like this. One day I would like to have a lab like this. And so what we did was, we wanted to do all these trials in collaboration with our customers. So basically, this is the work that we did in 2017-18, and we continue this work. But what we did was, we looked at different nutrients, immune enhancers, and stimulants, antimicrobials, and then we wanted to test them in farms. So this actually was produced as a commercial feed, and then we sent out to the farms for trying out. And two of the feeds were actually placebo. That means that we sent the regular feed; these were all coded, so only a couple of people know what is in the feed. The people who are receiving the feed do not know what it is, and then two of the feeds were placebo. And so these farms had white gut or white pieces, as well as we also chose farms in high-risk areas for white spot virus. And so we found that some of these products, some of these feeds actually worked really well, which means that the product that we included in them are effective products. And so you can see in this particular case, how feeding, for about 5 days, cleared the white feces. The one on your left-hand side is the pond that was infested with animals. The animals had a severe white feces problem. And after feeding for about 5 days, the white feces cleared in the same pond. Again, you can visibly look at the animals. The animals have white feces problem, and then which cleared up after the trial. So what we did was we found that among the 10 feeds that we tested, 3 of the feeds, so the components that were included in those feeds are effective in addressing the problem. It took 5 to 8 days of feeding to achieve complete control of white feces. And they were achieved in about 60 to 90% of the ponds tested. So there were still some of the ponds which were probably beyond the point of redemption that we couldn't do anything. But we control of white feces. That means that people are not saying this is a product that is working because of the because we say that it will work, but that when the feed did not have anything to improve, they were not working at all. So sometimes a feed can also remedy the situation. It's not the feed that is doing, but a change in the pond environment. Maybe another factor is in play. So how do we isolate the effect of the feed? That's why the placebo feeds are important. And then two of the feeds, delayed onset of white spot virus. And so these, 7 ponds that were fed with the feed in an area highly prone to white spot remained WSSV free, even though neighboring farms were affected. So based on these results, we launched a feed called NutriWave F15, and we continue to improve the feed. And even in 2019 and early part of 2020, before the lockdown, we had another 68 pond trials conducted, using some of the improvement things. And also we're looking at different strategies, like what a minimum level of feed that we need? Can we reduce the amount of feeding and still get the same result? All of that we are looking at it. So, so what is the take-home point? This is almost my last slide. What are the take-home points? So, aquafeed manufacturers and suppliers of the feed additives and supplements, require in-house R&D. We need access to live animals. So, when we have something, we always find that it's very convenient for us to, take the animals and try them out. And also, you can work with a university or a research organization, but it's very structured. And sometimes you may want to discontinue a trial and then redo it. Or even after you do the test, you want to redo it to make sure that you're getting the same result as you did in the past. So for all this, an in-house R&D is a requirement. And another thing that I would the suppliers and customers. This is an area in which feed manufacturers always have, they want to keep their suppliers at arm's length, and also they are concerned about working with customers. But then if you open and collaboratively work with them, you will always get good results. The thing is, no one has all the answers. But more the pieces you collect, sooner the puzzle will be solved. So it's important that we trust our suppliers and customers and be open to work with them. The universities and research institutions can be valuable resources. But one of the things that I realize is that a single institution cannot provide all the answers. So so then, we need to understand the strengths and weaknesses of each organization and be willing to coordinate project among multiple institutions. So we know that, this particular university is good in this particular aspect. This research institution is very good in this particular analysis, and things like that. So, so can we do a project, coordinating among different institutions? That is where the industry also needs to employ good scientists, these people who are trained well in their scientific disciplines to organize their research. That's very important. And finally, expertise and infrastructure capabilities are required not only in nutrition. So a feed company cannot limit itself to just nutrition work, but also in all related critical areas like health and environment, play an important role also. So you need to have capabilities in those areas. Either you can have in-house capability, or you have a strategic partner with whom you can work, or you can contract the work to a university or research institution. All of that will be important. And one of the things is we also value, since I'm talking this to an educational institution, we also value the work that comes from the public institutions. The publicly available information is extremely important for doing better of what we are doing at any time. So, so the public research is also equally important. And we need to take advantage of all these sources, in order to benefit from the things that we do. In order to ultimately, the benefit goes to the farmers, and that's what we are all working for. And it's important that we do this. So that comes us to the end of the presentation. For those who ever missed the start of this presentation, again, I would like to tell you that Society of Aquaculture Professional is opening memberships to students in aquaculture. So I would encourage every one of you to go and check our website, which is the aquaprofessional.org, and then check it out and consider becoming a student member in the future. That's it. Thank you very much, and I can take questions now.
Thank you, sir. Thanks for the wonderful presentation, sir. It's very informative, and particularly people who are concentrating on aquaculture nutrition. Actually, I have some few points, sir. In India, though shrimp aquaculture is at the top priority. Slowly nowadays, farmers are concentrating on other candidate species also. But seed and feed supply is the limiting factor for those other species. I'm not talking about shrimp. If somebody concentrating on milkfish or mullet, even from the previous talk, those farmers who interact with the sessions, they ask they don't have a feed for a milkfish or a mullet fish. So seed and feed is the limiting factor for the other species. So as an academician, I want to say that all the research people, they are working on particularly on creating a new kind of an aquaculture pellet or a feed ingredient, whatever they are working on it. So is it these feed industries, or as you being the representative of aquaculture professional society and you are the president of that, so I'm asking that whether these feed industries like the Global Innovation Center are like that, they will have back up those research people or young entrepreneur in that way. They help them financially or technically or whatever way. Will they back up them to come up with the new feed for the other candidate species? Will it be possible?
Definitely, it is possible. I want to tell you this. I mean, feed manufacturers always have, we always have this chicken or egg, thing, So basically, stimulation of an aquaculture, a new species or, a species that's not very popular, we cannot, we have to basically, any new species, there won't be enough feed available. And then people will say that, okay, if the feed is available, we can have the culture. But at the same time, the feed manufacturer, the challenge is that he wouldn't have the scale that is necessary. Okay. If you are asking for 300 kilos of feed, the feed manufacturer will not be able to provide you that. So they will say that, okay, if there are, you place a minimum order of 10 tons or 20 tons because our machines are scaled to that. That's the only thing that we can meet. We just cannot, provide you with the 300 kilos of feed. So that is the reason why we came up with this pilot plant also. If somebody wants even, like a 200 kilos of feed, we can make it in our pilot plant. Okay. So if it is a researcher, and then he comes with us and then say, we want to collaboratively work with you, we are open to that. And as a matter of fact, we are now getting involved with the cold water fisheries research institution in Beamtal. They want to stimulate trout production, and then we are now working with them. We just signed an agreement with them to work collaboratively on the trout feed. And again, the requirements are very less. It's like a few hundred to a few thousand kilos of feed, which is very difficult to produce, for everyone. But we have the capabilities to produce that, and now we are producing it, and we are now testing it. And this year we saw a massive difference in terms of the performance of the trout that were given the feeds. And so we are willing to do that. We actually made an agreement with them. We put their name on the feed bags. and we recognize them. So it's like a two-way relationship, where we can work with institutions on developing feeds for a particular sector. So if you have something, a unique species, for which there is a good market outlook, but at the moment, it's very small, we can work on that.
Thank you, sir. Thanks for the information.
Yeah.
Dr. Sheshadri sir is there. Vinit?
Yes, sir.
Sir?
Just a minute, sir. Sheshadri, sir, you can speak, sir. Sir, are you there?
Sheshadri sir, are you there?
I think
that is not there.
Internet connection is not well there, I think.
Okay, then we go with the, sir, shall we go with the question answer session?
Yeah, sure. Yeah.
Yeah.
Absolutely.
Yeah. Anup and Vinu, you can proceed, please.
Yes.
Yes. So, first I would like to unmute Dr. Ajay Kumar, sir. Ajay Bhaskar, sir.
Yeah, please.
Ajay Bhaskar, sir, you can continue, sir.
Oh, thank you. Hello, doctor. How are you doing?
I'm doing fine, Dr. Ajay.
Yeah. Just would like to know, you are doing a lot of research, and really it's a wonderful presentation, doctor. And I am going to have a presentation on 27th by same Sathyabama regarding fish nutrition and formulations.
Okay.
Evening 4 to 5. So I'm concentrating on mostly on fish, freshwater fish and marine fish nutrition.
Okay.
Just when I'm go through your presentation, I have seen that RES clear water system and a green water system. So can you tell me what is the growth difference and FCR difference you got between these two systems?
Yeah, we typically start the clear, both systems, the clear water and the green water, and even the cages, we typically start them at about 2 grams. Usually the outdoor cages, we start at 4 grams. Till then they are in a nursery system, and from the nursery, then we move them to these systems. In the clear water system, typically, the 2 gram shrimp, we get close to about 8 gram shrimp in about 6 weeks. Currently we are doing one trial, and that is the growth rate that we get in that system, in about 6 weeks. Sometimes we end the trial in 6 weeks. Sometimes we go up to 8 weeks. It's between 6 and 8 weeks, depending on what we are doing. That is in the clear water system, where we have the lowest growth rate. The green water system is typically about 1.7 to 1.8 grams per week, is what we get in the green water system. We do weekly sampling, that, if we reduce that, maybe we can get a little bit better growth. We are stressing out the animals quite a bit. So we get something, in the 1.7 to 1.8 gram growth, we get in the green water system. The outdoor cages are extremely good. We get nearly 3 grams. We get 2.7 to 3 grams a week. We can get in the outdoor system, largely because I think the shrimp are eating the algae that are growing on the cage material. So they get a lot of nutrition there, other than what we are providing in the form of feed. So we get really good growth in the outdoor cages. So this is typically the growth rate. Sometimes, when we want to have trials done on the large animals, we grow them in the outdoor cages and then we can move them indoor. But we have found some problems, with that. We are violating our biosecurity protocols. We get some bacterial disease problems and things like that. So we don't do that anymore. Now we have a strict biosecurity. You cannot go back and forth between the two systems. The two systems are separated. So we don't do that. But otherwise, this is the typical growth rate that you get.
Yeah, because I have some time back I have done some culture farming activity in the Bhimavaram area with related to the fish. In my pond, I didn't get maybe because of salinity or some other reason I couldn't get the plankton. So more or less, that required the blooms required for a proper growth. So more or less I have done a clear water this one culture of IMC, Indian Major Crops. So what happened? I have used the top 2 companies feeds, and the claim is 1.2, 1.3 FCR. But when I'm doing the same, culture, following their protocols and feeding table and all, so I found in a clear water system, I found the FCR around 1.8, almost 2.
Yeah, it can happen. I mean, the natural foods are very important, in the nutrition of the animal.
So I understand that, okay, then nearly 30 to 40% of the growth is coming from the natural food than the commercial feeds.
Absolutely.
So this is what I wanted to know with regard to the shrimp. Thank you.
Okay, thank you.
Okay, thank you.
Thank you, sir. Many compliments are coming from the participants that it is a wonderful and informative presentation.
Oh, thank you.
Yes, sir. So the next participant I would like to unmute is Dr. V.S. Chandrasekhar.
Oh.
Yes, sir. You can proceed, sir. Chandrasekharan, sir. Yes.
Yeah, my video is not coming.
Sir, but your audio is very clear.
We can hear you, sir. Since I know your face,
Good morning, Mr. Suresh and Inbakandan. And I think almost every day, for the first time, I am attending all the lectures of this continuous 5 days program. So
thank you, sir. Thanks a lot.
Because it is much related to my subject of interest. And thanks for the presentation, good presentation, Victor, as usual. And one just question that that has come to my mind. Feed conventionally and in the modern scientific aquaculture also, feed is playing a major role. With regard to the biofloc technology, what is your opinion? See, it's a high carbon system. And how far that is good for in long run? That is number one. And number two, how far our artificial feed can play a role so that ecological balance can be maintained. Yeah, can you tell me something about that?
Yeah. I mean, I think, when you look at biofloc technology, when it, caught everyone's attention, that probably, I would say the early work, is like at least 20 years old. And, when they came, the claims were made that, we even said, there was no need for a feed industry anymore. The shrimp can eat, whatever natural foods that are produced, and, they'll be fine. But that did not turn out to be the case. In the early days, they were talking about feeding the biofloc. They wanted to make, feed pellets that are very high in grains. And so if you look at all the early work, that was done in this aspect, grain pellets were produced and they were the sources of carbon. These were very low protein, about 16 or 17% protein. Rest of it is all grains, and they were feeding the bacteria and things like that. Eventually, it switched to more, I would say, user-friendly sources like molasses and so forth are being used as the carbon source. And if you look at the biofloc bacteria as a source of nutrition, some work has been done. Quite a bit of work was done in the early stages, where they were trying to collect the flock and then analyze the composition of the flock. And then people were saying that, okay, the flock can be a significant source of nutrition for the shrimp. But I don't think it is a very complete source of nutrition. One, it also has, for some reason, it is also deficient in some of the essential amino acids and so forth. So that idea of the biofloc being a significant source of diet, dietary nutrition for the animal, that did not really materialize. And I think the level of protein that you need in the feed in some countries, they went down. And we can say that, okay, if you look at all of Southeast Asia, the shrimp feed, the protein levels in shrimp feed vary from country to country. And if you look at countries like India and Vietnam, we have the highest crude protein in the feed. If you look at Thailand is somewhat lower than what we use in India and Thailand. I'm sorry, in Vietnam. But one of the lowest is Indonesia, and Indonesia is where there is a lot of practical application of biofloc in the farm. So I would say no one embraced biofloc technology as keenly as Indonesia. And if you look at the crude protein levels, that's where you see a 32% protein feed, being commercially used, and 33 to 35%. So there could be a factor. I mean, they probably are contributing to some extent, but it's mainly supplemental. It's just like when Dr. Ajay Bhaskar came and he mentioned, when you have a clean, a clear water pond, the growth of carp, gets reduced, and we see that in the shrimp, and even in when you look at biofloc in shrimp pond, they provide some other nutrition, but not all of it. Is what I would conclude. Yeah.
Thank you.
Yeah, you're welcome.
Thank you, sir. Thanks for joining us, sir.
Okay.
Thank you, sir. Shall we go with the next question? Or?
Please,
Sure.
please.
Yeah, thank you, sir. The next participant, I would like to unmute is Rakesh Janamani.
Hello.
Yes, Mr.
Hello,
Rakesh. Yes, sir. We can hear you. You can proceed.
Hello, sir. I have one doubt. Actually, as all of us know that in aquaculture, we feed the fish separate kind of protein feed in every stages of their life. So how we can improve the protein conversion ratio? Means how our protein percentage should be so that we can convert all the protein in the fish muscle or like that.
I mean, if you want to specifically look at protein conversion, one is a large part of it is the general system. When like we say, when you are using a fertilizer to improve the primary productivity in the pond, by itself, it is going to give you a feed free of cost. Basically cost of fertilization, which is very, very low, and so a fertilized pond is going to give you a much better result, than a clear water system. So by managing natural primary productivity, you can improve your protein efficiency a lot. I mean, you can, if you have a clear water system, maybe you have to give this feed, you have to give this fish a protein that's high, like a 35% or 40%. You can bring it down to 30 or 28, if your pond is rich in algae that the fish can eat. That is one way of reducing the protein within the feed. Probably one is balancing is important. Your feed need to be balanced because you don't want the protein to be used for energy purposes in the pond. Fish is somewhat is an animal that prefers to use protein as energy, so it's inevitable. But you can reduce that by providing the energy. For example, lipids can be a source of energy. That's what they found in the case of the salmonids, is that by increasing the protein, you can reduce actually your protein. By increasing your lipids, you can reduce your protein. So that cannot be applied to all the species. Only in the cold water fish, in the salmonids, you can do that. In some of the carnivorous fish, you can do it. In the herbivorous fish, the carbohydrates are much more important as energy sources. So again, if you provide an available carbohydrate source, then you can actually reduce your protein. Thirdly, what you can look at is the enzymes. You can use an enzyme like specifically in this case, protease. Even phytase has an effect on protein digestibility. So by using phytase, by using a protease, you can increase the protein digestibility and you can improve the efficiency of the feed. So basically, it's a multiple ways to reach the solution, and you can use any of them.
Thank you, sir. Next, I would like to unmute Praveen Prasad.
Yes, sir. My question is, through fermentation, we increase the protein value in the feed. Any guideline regarding what type of a probiotic or prebiotic we use, so that what is the process of fermentation by your companies or by your research, sir?
Mean to say that you put the probiotic to somehow ferment. I mean, this is So you're talking about not using a feed, but an ingredient that you can use, or a mix of ingredients, or, I mean, I'm not very clear, because typically, in the industry, they feed and then they apply the probiotic. They go separately. But if you want to improve the raw material, you can subject them to, a specific fermentation, on that ingredient. And there are now ingredients that are being produced like that. For example, you can ferment soybean meal. There is also a cottonseed meal that is fermented and being made available. So specific ingredients can also be separately, fermented. And then when you look at the commercial angle, they are then dried and then, come to us as an ingredient. And again, they use different kinds of species. A large number of fermenters actually use a bacillus to ferment soya and cottonseed meal. That is the predominant mechanism of fermentation of these ingredients. But there are, multiple ways of doing that. And now I understand that even rice protein, it gets fermented. It gets hydrolyzed and then, converted into a product, that can be included in the feed. Years ago, and even now, I think some people are doing that, is to use, these probiotics. I'm not sure if I can specifically recommend, because it depends on the property of the bacteria to produce, what it needs to degrade in the ingredient. Some of these bacteria produce cellulases, for example, and so they can work on very fibrous ingredients and take down the fiber content. And people used to do a on-farm fermentation of soybean, and they would use a mix of species, bacterial species. And there were, at that time, there were people who would come in and then, give them some spores, and then, have the farmers, subject the soybean to a fermentation, and then apply the fermentation. And now we see that rice bran, people are now using rice bran fermentation. And I'm seeing that many of them are using just commercial blend of probiotics. These are mainly different species of bacillus that are available. I think multiple products are available now. I can see, 20, 30 products that are available in the market. And these are being used to ferment rice bran and or rice polish, actually. And then that's being used in the pond. It's can be consumed by the animal, or it can be consumed by the different zooplankton and other things, and then they become the food of the animals that you grow. So on that part, the science is too early, but farmers are doing a lot of innovation, like, for example, on pond, on the farm fermentation using commercial probiotics and things like rice bran. Yeah.
Thank you, sir. Thank you.
Thank you.
Thank you, sir.
Sir, as we don't have any more questions and we have exceeded the time, I think, sir, I would like to.
Okay. Vinith, thanks for the information. Seshatri sir is there. We can ask him to give a concluding note on this. Otherwise, we can end this program.
Seshatri sir is here.
I don't know, sir is still with the phone, it seems. Sure. I think sir is still, no, I think he is being in the phone, it seems.
Okay.
Okay. Thank you, sir. Thank you, Suresh. Actually, I want to say that Raka is my good friend, and he only gave you a number to contact you. And I really happy to be in association with you, and I'm happy to hear your presentation. Actually, it's very simple and it's very clear, and it gives a lot of idea to our research people. Because even in our center, we are working on nano-based formulation and herbal-based formulation on that thing. And we had some kind of even to say that we don't know which is the way to connect with the industrial part. Maybe this kind of innovation center and the talk, whatever we listen from your side, it's a very helpful for us. And thanks for the wonderful presentation, sir. Thank you.
Thank you very much. I think, I enjoyed talking to the whole group. It's good to know, this is an opportunity for me to get to know about Sathyabama University. Also, I've heard the name, but I didn't know that they were doing anything on aquaculture. So it's a revelation for me that that you have a good program there and you've organized this very useful seminar. And I'm glad to see, a lot of known faces like Dr. Chandrasekhar and Dr. Jeppiaar, and a lot of other people, most of the people I do not know. So I would like to say thank you for giving me this opportunity to talk here and share some of my thoughts. Please stay in touch, and I gave my email address. So everyone knows that. Yeah.
Sure, sir. Actually, we have a technology business incubator, which we are purely working on marine-based resources only. That's what I thought to have a. Dr. Sheshadri sir, he is the advisor of our technology business incubator. So, but he is on another call, so that he is unable to join here. Anyway, thanks, sir. We will be in touch, sir. Thank you. Thanks a lot.
Okay, thank you very much. Bye bye.
Thank you so much, sir. Thanks for a wonderful time, sir.